In math, we have a property called the transitive property. For example, if x equals 7 and x equals y, then it should follow that y equals 7. So these first two are the premise, and the conclusion is that those other two things are equal to each other. And so that's the law of transitivity in mathematics when it comes to equal signs. However, we also have a transitive property or a hypothetical syllogism when it comes to if-then statements. If we have these two premises where we have if this happens, then this happens, and then if this happens, and these two things are the same thing, then this happens, then we can cut out that middleman and say, if this happens, then this happens. And that's what we have in our conclusion here. Sort of like if x equals 7 and x equals y, then y equals 7. It's sort of that same idea. And from that, we can conclude that a conclusion is valid. So let's see if this example follows this transitive property. If I work hard, so let's say that's H, then I will get a raise. And that's R. So H, then R. If I get a raise, then I'll buy a boat. So we have R, arrow, boat. Now, here's another thing. If I don't buy a boat, then I must not have worked hard. Now, according to the transitive property, if we have H, then R, and R, then B, then the conclusion should be H, then B, according to this transitive property. That's not what we have here. However, this is another property called the contrapositive. And with the contrapositive, we switch around the H and the B, and we negate them, make them negative. And in this way, when we're working on these premises and conclusion, we don't put a negative sign, we put these little swirly things called tildes to mean not, because we don't use negative signs. So are these two equivalent? Yes, they are. Have we used the transitive property? Yes, we have. So the other conclusion we can draw from the transitive property is that not R, arrow, not P. So both of these two conclusions are a result of the transitive property. Is this argument valid? Yes.